Good afternoon, everyone, and thank you for joining us this afternoon on the latest ECA Learning Zone webinar. Today, it's all about emergency lighting. Today's presentation is brought to you by ECA Commercial Associate NVC Lighting. We're delighted to have their technical manager, Peter Adams, with us today. He'll be your main presenter. We also have Phil Brown, Director of Products and Marketing, who will be on hand to help answer your questions in the Q&A session at the end of the webinar. We also have ECA's technical manager, Shahid Khan, who I'll hand over to very shortly to kick off the webinar and introduce today's topic. But before I do that, just a bit of housekeeping. I'd like to remind you that you can use the questions box, the little question mark button on your screen at any time during today's presentation to ask a question, and our presenters will answer as many as they can at the end of the webinar. Today's session will be recorded and a full replay will be available on ECA's YouTube channel. That's at youtube.com/ECA Live. Be sure to also check out our other replays from the entire ECA Learning Zone series so far, covering other technical and business topics. With that said, I hope you enjoy today's session, and over to you, Shahid.
Thank you, Omar. Hello, everybody. Welcome to this presentation on emergency lighting. Obviously, the main presentation will be done by NVC Lighting and Peter Adams, but I've got a couple of slides that I'd just like to go through just to introduce the topic a little bit. Omar, next slide, please. Okay, so emergency lighting is actually a legal requirement to ensure that all non-domestic buildings, that includes houses of multiple occupation, remain safe at all times. Just to sort of introduce some of the legislation that applies, we've got the Health and Safety at Work Act, which talks about securing the health and safety and welfare of persons at work. We've got the Management of Health and Safety at Work regs, which talks about doing risk assessments to ensure that we minimise and control danger. We've got the workplace regs, which basically say that every workplace shall have suitable and sufficient lighting. We've then got the building regs and approved document B, which talks about lighting in the form of escape lighting. And we've got the regulatory reform order, which again talks about fire safety and associated emergency lighting, but from an escape perspective. Next slide, please. Essentially, in the event of a power cut or an emergency, emergency lighting provides illumination such as to facilitate safe evacuation of the premises and or prevent panic. If you look at the diagram on the right hand side, you can see that emergency lighting is almost a generic term, and there's various other terminology that sits underneath that. So we've got emergency escape lighting, escape route lighting, open area lighting, and high risk task lighting. We've also got standby lighting as well. There's a number of British and harmonised standards that cover emergency lighting. I've just mentioned one there, BS 5266, which I'm sure Peter will cover in more detail later on. But really, it's sort of a flag there for our ECA members. For those that haven't got the BSI offer, we have a package that's available where you can purchase over 80 standards for about 100 quid excluding VAT. Which for anybody that's tried to buy any sort of British standards, you know how good of a deal that is. For further information on that, just contact your regional managers. Next slide, please. As regards to myself, the bits that I'm looking forward to finding out a bit more on is the improvements to battery technology and advice on better maintenance regimes. So they're the bits that I'm looking forward to in terms of the presentation. As Omar said, there will be time at the end for Q&A, but feel free to put them in the chat as we're going through. So without further ado, I'll hand over to Peter Adams, the technical manager at NVC Lighting.
Thank you, Shahid, and thank you everyone for joining today's session. Good afternoon, everybody. My name is Peter Adams. I'm the technical manager of NVC Lighting. I've been in this role for about 18 months, but I've worked in the industry for almost 30 years. So I'm based here at our offices in Birmingham in the West Midlands. Okay, next slide, Omar. So we're going to talk about emergency lighting in a little bit more detail. The topics we shall be covering in the session are emergency lighting, obviously, what is it, where should it be used, and why must it be used. We're going to cover some essentials for contractors and talk about certain details that your clients need to know. And we're going to talk about how you can use your knowledge to enhance your reputation whilst generating more business and more reputation amongst your customers. Thank you, Omar. So, emergency lighting, what is it? So emergency lighting is lighting which is provided for use when the normal lighting supply fails. That in a nutshell is what emergency lighting is. But as Shahid already alluded to, emergency lighting is kind of an umbrella that covers various different forms of emergency lighting. And these, as outlined in BS 5266, are emergency escape lighting, emergency safety lighting, and standby lighting. And the main differences are that emergency escape lighting is lighting that is provided to enable the most efficient and safe evacuation of a building in such times of a power outage or fires or any danger to the building. Whereas emergency safety lighting is that part of emergency lighting which allows occupants to stay in the building for periods up to but not encroaching on the final hour of the battery's duration time. So if there is daylight in the building and it's deemed that it is safe to continue to operate in the building, then that's where we would use emergency safety lighting. And then we have standby lighting. Standby lighting is still emergency lighting, but this would be provided by typically generators or UPSs, uninterrupted power supplies, things like that. And these are provided to give you 100% output in an emergency situation. This is typically in areas such as operating theatres in hospitals, where if you're performing an operation, then obviously that operation can't be postponed midway through. So an operating theatre would then switch over to an uninterrupted power supply, providing full output in those conditions. And where is it needed? Where do we apply emergency lighting? So in virtually all commercial premises, it's exempt from residential buildings, other than buildings which may be houses of multiple occupation. So they have communal areas that would be used by different tenants or people. So we'll talk about commercial premises. These aren't just business premises where there may be employees. These are also places of worship, also hospitals and care homes, anywhere where there might be patients. So emergency lighting is quite crucial in these areas. And why do you have to install it? The Fire Regulatory Reform Order, which Shahid has already mentioned, was an order that was produced and published by the Health and Safety Executive under the mandate from the government. And this was produced in 2006. That's when it became law. And this mandates that fire risk assessments must be undertaken in commercial premises to ensure that occupants are safe at all times during their working hours or in the hours that they reside in these buildings. And it also says that emergency routes and exits must be equipped with adequate emergency lighting. Thank you, Omar. So the risk assessment, as mandated, this is quite a heavy-duty task for someone to undertake. It must be done by a competent person or a responsible person that is given the task by the competent person in the building. The competent person in the building would normally be the building owner or the head occupant of that building. And so it is a big task to perform this, but fortunately documentation is available to help the fire risk assessment, particularly in the area of emergency lighting. So if we look at certain documents that are available to us, firstly we talk about BS 5266 Part 1. This is the code of practice for emergency lighting in commercial premises, and this almost serves as like a one-stop shop. So if you have a copy of that standard, then that includes references to all the particular standards that would be required in order for you to design, install, implement and maintain a compliant emergency lighting system. And two of the major standards that are incorporated within BS 5266 are BS EN 1838 and BS EN 50172. BS EN 1838 covers lighting applications for emergency lighting. So this deals with all aspects of the design of the system. It tells you how many fixtures are required in fire compartments and open areas and escape routes. And it talks specifically about which products are needed for high risk task areas. And then we have BS EN 50172, and that's the part of BS 5266 which mandates the test regimes and schedules that must be used on monthly and annual basis. Okay, thanks, Omar. So how does it work? How does emergency lighting work? Well, it uses secondary cell batteries as its power source. If we talk about secondary cell batteries, a secondary cell battery is merely a battery that is rechargeable, as opposed to a primary cell battery, which is a non-rechargeable battery. So the battery is what the lighting takes its power from in an emergency situation. So the battery remains permanently charged via an emergency control module throughout its normal operation, and that is fed by the permanent live supply in a building. And when there is a loss of power, the hold-off relay, which is kept off in normal operation, switches over, and the battery then discharges to provide illumination in emergency mode. Okay, thank you, Em. There are two different kinds of emergency lighting system that you may be familiar with, certainly in the UK. So these would be typically centrally powered or a central battery system or a static changeover system. And that is typically reliant on sealed lead acid or valve regulated acid batteries. It uses these because they offer a very long life and performance, which make them ideal for these systems. The way the centrally powered emergency lighting works is that you would have typically a cabinet of batteries, a very high capacity of batteries in one area of a building, and this then feeds a multitude of emergency inverters, which allows a number of different emergency lighting fixtures to operate in emergency. And then we have the self-contained or single point emergency lighting system. This is the one that we'll be talking more specifically about in today's session. So a single point emergency lighting fixtures are luminaires which contain all the components that are required to operate them both in emergency and mains operation. And these are all housed either integrally to the luminaire or within 1 meter of the luminaire. Thank you, Omar. So how do we choose our emergency lighting? Well, the choice of emergency lighting will affect energy usage, the maintenance regime. It'll affect the compliance with legal requirements, and ultimately it'll affect costs. So if we talk about energy usage, it's important to remember that emergency lighting is what we call parasitic energy, or it uses parasitic load or energy. So unlike non-parasitic energy, which may be, for instance, a television or a radio. So when this is on, you know that it's on because you're either listening to music or you're watching images from your TV screen. It could be a kettle that you know that it's boiling water. So, but emergency lighting is what we call parasitic. So it's typically always in standby mode. So you may see, and you'll be familiar with the little green charge indicator, but you won't see anything happening until the power is lost. But what you must remember is that throughout all its life, that the battery is being charged, and so energy is being used. Okay, Omar, thank you. So if we talk specifically about the parasitic load, the type of battery that you use can have a dramatic effect on this and the sustainability of the system. So the way the battery is charged can be quite crucial to certainly energy savings. We must remember that energy is lost as heat. So obviously when a battery is being charged, it has current going through it. So if you look at the two main types of charge regimes for emergency lighting batteries, we have constant current charging and we have intermittent or multi-level charging. So these have different effects on the amount of energy that is lost throughout the life of the emergency lighting system. Okay, thank you, Omar. So if we look at the battery technologies individually, typically the batteries used within emergency lighting systems would be, certainly for self-contained emergency lighting, we would historically have used nickel cadmium, and then later on we used nickel metal hydride types, and more recently we've begun to use lithium technologies. So if we look a little bit at nickel cadmium to begin with, it's a mainstay technology for emergency lighting systems. It's a very robust battery and it has a high temperature tolerance. So this makes it robust and durable in harsh environments. So what do we mean by harsh environments? So obviously if a nickel cadmium battery is inside a luminaire, then you can understand that it would be impacted by heat and by the current going through it. But it readily accepts a constant current charge. The downside of nickel cadmium is that it has a very low energy density, which means it's quite a big battery for the amount of capacity in it. And this in turn makes it a little more difficult for conversions of luminaires or placing into luminaires that typically get smaller and smaller as technologies change to LED technologies, for instance. Thank you, Omar. So if we look at the next chemistry, nickel metal hydride or NIM, this is a greener alternative to nickel cadmium. It has no heavy metal content and a low percentage of hazardous chemicals, which makes it easier to recycle. And it has a reduced energy usage. So it's about 30% less energy. And this is because it doesn't use constant current charging. A nickel metal hydride battery responds far better to what we call intermittent charging or pulse charging. And this basically means that what happens is once fully charged, the battery will be rested for a period of time, typically anything between 7 and 10 minutes or 70 and 90% of its charge period. It will be rested, which allows it to cool down and of course saves energy. And then it's top up charged as a ratio of maybe 30%. It has a higher energy density than NiCad as well. This means that it's a slightly smaller size battery, but it has the same sort of capacity. So it is more suitable for luminaire conversions. But it's less tolerant to high temperatures and it's not as robust in harsh environments. So it does have its downsides. If it is constant current charge, then it is susceptible to a phenomenon that we call voltage depression. And this is when the battery suffers from a depleted voltage because it is being charged incorrectly. And when it reaches this sort of level, then it becomes unrecoverable. So it should not be constant current charged. Okay, thanks, Omar. And then we come to lithium. Lithium is the newest technology in emergency lighting, but it's certainly hit the industry. It's hit the ground running, as it were. It has a very high density energy, which makes it an ideal choice for luminaire conversions. The cell chemistry itself is perfectly set up for rechargeable battery-powered emergency lighting. It's has a high temperature tolerance, similar to NiCad, even slightly higher than NiCad, so it will withstand temperatures up to about 55 degrees C. And again, like nickel metal hydride, it has no heavy metals, so it's much kinder to the environment, easier to recycle. Thanks, Omar. So there are different types of lithium batteries, but the main one that is used in emergency lighting systems is lithium iron phosphate, or LiFePO4. And LiFePO4 conforms with the relevant standards, IEC 62133 and IEC 60951 for safety and performance, and it is our preferred chemistry for the industry. So you may have heard that overcharging of LiFePO can produce volatile chemical reactions, and you may have also heard that LiFePO4 technology may have been described as a potential dangerous chemical. Yes, all chemicals can be dangerous, but it's important to remember that when used in emergency lighting systems, there is always an overcharge protection circuit that is used in conjunction with the battery. This may be included on the control gear that is compatible with the battery, or it may even be included on the battery itself. But with this in operation, LiFePO4 is perfectly safe to use for emergency lighting systems. And as well as its substantial energy savings, it has an extra long life. So up to 8 years, depending on the temperatures that it's being used in. And it also offers considerable reductions in maintenance and obviously environmentally friendly recycling. We at NVC call this technology lifesaver because for our benefit, it saves lives and it saves money through lower cost running, maintenance, and it also saves the planet. Thank you. Okay, Omar. Thank you. So if we look at energy usage in particular, so if we're looking at a typical luminaire that uses NiCad technology, because of how it's charged, it is being constant current charge. So if we look at maybe a regular non-maintained 3-watt emergency LED luminaire, then if it's typically 3 watts of power that it's giving, it is consuming almost that again in terms of the power that it is that is going into it. So a typical 3-watt emergency luminaire using NiCad consumes 2.8 watts of power, whereas a non-maintained 3-watt luminaire using NIM consumes around 2 watts of power. So that brings about energy savings in itself. But the intermittent charge cycle applied to lithium battery technologies, coupled with a much lower self-discharge rate, this is 3.5% capacity loss per month compared to 10 to 20% per month for NiCad. This results in even more energy savings, around 40% less than NiCad. And in financial terms, if we assume an electricity price of about 14 pence per kilowatt hour, then we can see that the annual saving per emergency lighting fixture using LiFePO4 technology is around £2.25 per kilowatt hour. Now, that's quite important if you consider that in one particular installation, you may have anything up to around 500 emergency lighting fixtures. So the savings for across energy savings is very tangible indeed. Okay, Omar, thank you. Just to illustrate that, you can see from this slide that as a comparison of LifePole 4 versus NiCad, the annual power use in kilowatt hours of a typical IP65 bulkhead, which would be maintained for 24 hours, 7 days a week, a fixture using LifePole provides a 40% saving of parasitic energy in comparison to a fixture using NiCad. So it really has dramatically changed the way we approach emergency lighting systems. Emergency lighting was always seen as perhaps an unnecessary evil that was required for lighting systems. We much prefer to think of it as a safety critical system rather than an addition to a lighting system. However, with more discrete luminaires on the market in these days, and coupled with these really adaptable charge regimes, there's no reason why we can't use more and more emergency lighting to generate even further energy savings. Thank you, Omar. So just a little bit about battery maintenance, just touching on good practice in design and use. According to the luminaire standard for emergency light, self-contained emergency lighting, the battery must satisfy a 4-year design life. So what we know is that lithium, if used correctly in its correct operating parameters, will last almost double this, up to 8 years. So, but diligent battery maintenance and operation is critical to avoid damage. You must remember that batteries are consumable items and they are susceptible to damage through accidental misuse and abuse. So it's critical to operate them within their correct working parameters. Always refer to the manufacturer's instructions to do this. Always remember that the luminaire and or the battery must be replaced when they no longer provide their rated hours of duration. Typically in the UK, this would be a 3-hour duration system. And it's even more critical that batteries must be replaced with identical types if you're replacing the battery. If you have a luminaire which has used a control gear which is compatible with NiCad battery packs, then it's absolutely paramount that you can't replace that NiCad battery with a lithium or a nickel metal hydride battery. Okay, so just a bit more on good practice. So powering up, so the battery and the control module must be compatible. So if you're undertaking the design of emergency lighting system, or if you're undertaking a conversion of a luminaire, you must ensure that the battery and the module are compatible. The control module, the emergency lighting, must always be powered by a permanent or unswitched live supply. So you can't switch emergency lighting. If you have emergency lighting on a switch live supply, then obviously every time you turn that lighting off, the battery would start to discharge. And then if you turned it on again, it starts to charge, but it doesn't have sufficient time to recharge fully before it starts to discharge again. And connection of the battery, when installing the batteries or when installing the emergency lighting, connection of the battery to the module should be made at the latest possible stage before the installation is given full power. Okay, thanks. So in order to improve the maintenance of the battery and the emergency lighting, we have to refer to the test regimes that are set out in BSEN 50172. If we do this properly, then obviously we secure a 4-year design life in line with the standard. It's important to have the effective testing regime to do this. So in line with that standard, the testing would consist of 1 full rated duration test per year and 1 full functional test each month. And the functional test is mainly just a switchover test, just to check functionality. And this Can be as little as around 30 seconds. Typically, that's what you would expect to see it for, but it can be up to 10% of the full rated duration. So anything up to about 18 minutes. But anything more than this is not really required. You know, the frequency is there to be followed, and you know, too much testing can be detrimental to the emergency lighting. So this can be done by maintenance teams and facilities teams, perhaps being over diligent. So they're maybe testing the emergency lighting too much because they want to make sure that their occupants in their building are safe and that the emergency lighting is still compliant. But there's no need to do this. You know, one full duration test a year and one functional test per month is perfectly adequate. Okay, thanks, Omar. So for optimum performance, the feed at the emergency module must remain permanent. Each control module includes what we call deep discharge protection. This is a device in the control gear which effectively cuts off the battery supply when it reaches a certain voltage level. And it does this to save the battery from discharging to critical levels, which may result in the battery becoming non-recoverable. The lower the voltage in the battery, the more detriment that will give the battery. So deep discharge beyond this level will eventually damage the battery, and in certain occasions can lead to what we call cell polarity reversal. This is when the battery short circuits itself internally and is not recoverable from this position. Okay, thanks. So just to summarize that, what we would always say is if you can ensure your client's emergency lighting systems are designed and installed to meet the legal standards, and ensure your clients know their legal responsibilities for testing, you can also help them to establish an effective maintenance program that will identify when you will need to replace luminaires and/or batteries. It's a really good time for emergency lighting systems and the installation of these systems, and I think it's probably a time that has never been better for contractors to impress onto their clients and their installations that the installation of lithium technologies in particular can really help to bring about substantial energy savings, extra long life for their emergency lighting systems, and this of course will result in fundamental savings both financially and in terms of parasitic energy savings. Okay, thank you. So it just remains for me to thank you all for your attendance and thank you for your time, and hope you've enjoyed the session.
Brilliant. Thank you very much, Peter, for that very detailed presentation. Really great stuff. We'll move on now to the Q&A. There aren't any questions from the audience yet, so don't be shy. Please do put your questions in. Shahid, I think you had a couple of questions yourself for Peter.
Yes, thanks, Omar. I do actually. Thanks, Peter. That was a really good presentation. Very detailed. I wondered whether you could just expand a little bit on giving us some tips on improving the life of batteries in order to avoid damage to the things. Is there anything that we should be doing or not doing?
Yes. So if I put my different hat on, one of my areas that I work in is after sales, and one of our most frequent after sales issues is with premature failure of the battery, and it can always be difficult to prove how this has occurred, because typically the battery in emergency lighting systems will only manifest its damage in time, but typically the damage occurs. We see this in the early stages of pre-handover installations, and this can come about through over testing or many different power outages, and it can also come about because the battery may in some areas have been wired to the switch live supply rather than the permanent live supply. So as I said earlier in the presentation, it's critically important that the emergency lighting is fed from a permanent live, so you can't switch your emergency lighting. What has happened in the past, and I know that people are learning more and more about emergency lighting as time goes on, but we've seen occasions where in the early stages of installations, before even the second fix of lighting switches and sockets and things like that, typically people would come into a building, maintenance teams or contractors, and they would just switch all the lighting on in the morning, which included switching the emergency lighting off or into emergency lighting, and then when they leave at the end of the day, they would switch the lighting off, which of course starts to discharge the battery, and that only needs to go on for a matter of days before the battery suffers potentially irreversible damage. So it's critical to look after the battery properly, use it within its correct parameters. So always refer to the manufacturer's instructions, but definitely keep the battery supplied by the permanent live supply.
Cheers. No, that thank you. That really helps. My only other question is perhaps it's a little bit unfair because it's not part of the presentation, but it was on sort of an automated solution in terms of emergency lighting. Do you have anything? Is it a DALI-based system? Can you give us a bit more information about the other offerings that NVC Lighting have for a smart solution?
Yes, so obviously when we talk about emergency lighting, emergency lighting can be as basic or as intelligent as you want it to be. And the three, shall I say, two platforms of emergency lighting. One is basic emergency lighting without any onboard test facilities. So this would be just a standalone module. It's probably the most economical in terms of upfront outlay of costs, but maybe throughout its life it can prove more expensive because it requires manual testing, which means obviously human intervention to undertake these tests. And then you have what we call automatic testing emergency lighting. So this would be emergency lighting modules with onboard test facilities. And what happens here is that emergency lighting system will test in accordance with BSEN 50172 without the need for human intervention. So it does this automatically, uses a microprocessor unit in the control gear to do this, and it will do that in line with the standards. So it will do automatically a 30-second flick test per month, and it will do an annual duration test. And the way to check that the emergency lighting system here is still compliant is just simply to have a routine walk around and check the charge indicator, check that that's still green, and that's telling you that everything's good in that system. But we can take it one step further than that then, Shahid. If we offer then an interface such as DALI, so a digital addressable lighting interface to the automatic test system, then not only will it test in line with the standards, but these tests can be scheduled, and they can be scheduled to operate at times of low risk when a building is not occupied. This is very important, so that because obviously if the emergency lighting tests at all one time, then the batteries are subsequently recharging at the same time, and that may provide a risk that the emergency lighting is not compliant for a certain period of time. The great thing about DALI is that it operates on a subnet basis. So each subnet on a DALI system can take up to what we call, 64 different emergency lighting fixtures, but these can be grouped into 16 different test groups. So the testing then is much more manageable. It's still all testing, but it's not all testing at the same time. So effectively, the building remains compliant. So certainly DALI systems have been around for a long time. In my opinion, for the reporting, scheduling of tests and monitoring of emergency lighting, then we would always recommend that is the route to go down. That in itself brings about savings in maintenance, facilities, and yeah, it's certainly one of NVC's offerings. We have all of our dedicated emergency luminaires can be DALI compatible if required.
Yeah, I appreciate that. Thank you. Yeah, no, it sounds like that's a good way to go. Even if you were to factor in the damage element to the batteries, it sort of takes the human error bit out of the equation, doesn't it? So yeah, no, that is interesting.
Yeah, there's another standard that's included in emergency lighting, which is the automatic test system standard. This is BSEN 62034, and that standard in itself talks specifically about the opportunity for neglect in terms of emergency lighting testing. What we do find is that historically in manual test systems, for the annual 3-hour duration test, if you're looking at testing maybe several floors of emergency lighting in a building, the question would be, would you be confident that you can accurately reference that all of those fixtures have either passed or failed a 3-hour test? It's a lot of fixtures to go around and check after a 3-hour mark, and so manual testing can be susceptible to neglect. It's very susceptible to inaccuracies. With a self-test system, and particularly a DALI self-test system, that won't occur. In line with the DALI standard, there is like an onboard clock in the control gear, which cuts off the battery supply after 180 minutes, so 3 hours exactly. So if there's a self-test and then you come in and have a look at that fixture and it has a green indicator, then you know that it has passed the full 3 hours duration test.
Yeah, thanks Peter. Thanks Shahid. We have one question from the audience. At the beginning of the presentation, you mentioned that emergency lighting is of course a legal requirement, but the question is it a legal requirement for all old buildings as well? This person says they see a lot of buildings every week without emergency lighting that are much older.
So any building that has public or private occupation of more than 10 people requires emergency lighting. That is a legal requirement, and we see this from time to time, particularly with listed buildings and buildings of high importance, prestigious buildings. There is a tendency for them not to want emergency lighting because they don't want to detract from the aesthetics of the building. But if the building is for commercial use, whether that's a National Trust building or a museum or an art gallery, if the building is for use of patients, it doesn't matter how old that building is, that building must have emergency lighting.
Great, thank you, Peter. There are no more questions from the audience, and I think that would be a good place to wrap up today's webinar. So a final massive thank you to you, Peter and Shahid, for presenting today. Peter, where can people find out more about NVC?
So they can visit the NVC website. Phil may be able to give us the address of the website, but obviously www.nvc.co.uk. So just visit the website, or you can call us at our office in Birmingham. We have, a sales office here, sales and distribution, and we have a technical support team. So by all means, if anyone ever needs to contact us, they can do that through the website or on LinkedIn. And I'm sure Phil knows of more avenues that we can be contacted on.
Yes, Peter, if you can here, the website's actually on your final slide in front of you. As Peter says, LinkedIn, just Google NVC Lighting. We've got quite a good sort of web presence. We've got some really good technical support documents on there, not only about emergency lighting, but various aspects of lighting that may be of interest to any of the users today. And I'd recommend coming and have a visit and have a read. All sorts of stuff about DALI and SDCM, chromaticity, macadam ellipses. It's all on there, so it's a great place to come for some knowledge.
Great, thank you, Phil. And just a final reminder as well that today's session is recorded and will be available very shortly on ECA's YouTube channel. That's at youtube.com/ECA Live. And we'll wrap up there for today. Thanks again, everyone, and enjoy your evening.
Thank you.
Thank you all.
Thank you.